Alright, finishing up this problem. This right here, the sine of x would be equal to 1 over the square root of 2, which is the same thing as square root of 2 over 2. And so, where does this happen in this interval right here is at 45 degrees and 135 degrees. So, I will take those two numbers and put them on a number line, which is 45 degrees corresponds to pi over 4, and 135 degrees corresponds to 3 pi over 4. We need to test the interval. The only interval I'm going to try is right here, pi over 2, because this is a polynomial. I know they'll just change signs after that. I'm going to actually take that right up here and plug it in. So I actually want to think about this as being 1 over the sine of x squared. And I'm going to put in pi over 2 like I said. So I'm really thinking, what is the sine of pi over 2? Sine of pi over 2 is right up here. Is equal to 1. So 1 over 1, this is 1. 2 minus 1, oh, that's a positive answer. That means that these have to be negative on the other sides of them. Because it's a trig function, I know that is going to change, increasing and decreasing. The second derivative then ends up being the derivative from right here. So the derivative of 2 is 0. And then the derivative of cosecant squared. It may be easier for me to first rewrite this first derivative. So the first derivative would be 2 minus cosecant x squared like this. Now it'll be much easier to take the second derivative. So I get 0, bring down the 2, negative 2 cosecant x times the derivative of what's inside, which would be a negative cosecant x cotangent x. So the second derivative needs to be rewritten as 2. I have cosecant squared x and cotangent x. Well, I'm going to have a hard time setting that equal to 0, so I'm going to actually change it all into sines and cosines. So I have 2 times 1 over sine squared x times cosine x over sine x. So that would really give me 2 cosine x over sine cubed x. The bottom is not going to give me 0 in this interval because we're talking about an open interval. The top, I'm really asking myself, where is the cosine x equal to 0? And that would be at pi over 2. So it's going to change concavity at pi over 2. When I test this into my second derivative, when I plug in, say, pi over 4, I know that both of these are positive in pi over 4. So I know it's positive over here, where only the sine is positive when I plug in 3 pi over 4 into my second derivative. So this one has to be negative. This is just a sketch. It doesn't ask me to find intercepts or any of those other things. So I will not find those. There are no vertical asymptotes, there's no horizontal asymptotes, and none of those things. And I'm only talking about from 0 to pi, so that's only part of the graph I'm going to make. So we're going to just have pi over 4 and pi over 2 and 3 pi over 4 on the graph, as well as pi. And this is definitely not what your graphing calculator will show you, because I did not actually find those exact points, because all it did was ask me to sketch this, didn't ask me to use the exact sketch. So I'm going to decrease all the way to pi over 4. So I know there's a minimum right here, and then it's going to increase again all the way to 3 pi over 4. And this is all concave up, and then it changes over to be concave down, and it starts to decrease at that point. Again, this is not exactly what your graphing calculator will show you. You can punch it in your graphing calculator. You'll get something similar to this, where the concavity and the increasing and decreasing are the same, but it will not be the exact graph because we never found exact points on the graph.